Okay, release planning. Want to start with platform?
This is an interesting one because I haven't been all in the loop. So I'm hoping maybe someone can fill in the gaps. But my understanding is that David is planning to do a pack release at some point today. I don't know in what time zone that is. But yeah, that's something on the rise there.
Okay. Any updates for implementation team? Release planning?
I don't think so. Natalie released last week, I believe, wasn't it? Yeah, or a draft release is up. So I think. Okay, we did release 3 days ago, so I don't think there's anything else to add.
Okay. No updates from distribution. BAT team, any release planning updates?
We're all up to date on the latest platform and build back APIs.
Any spec release planning?
I think we took care of that yesterday at the core team. I think for the sake of the people in this meeting, there are 2 spec releases that we're working on, distribution and project descriptor. I think project descriptor is probably at the forefront. And I think Joe, you might be have a little bit more context on exactly when we're trying to ship that. But then soon thereafter, we're trying to get distribution spec out. And so we could get the builders all in line and compliant.
Okay. Should we jump into the rest of the agenda?
Sounds good to me.
Cool. First one is proposal to move to CNCF Slack.
I think Terrence, oh yeah, Terrence is here, but there isn't much. I think it was just an FYI that RFC exists, and we're looking into moving to the CNCF Slack. There are still some open questions, and we filed a service desk ticket on our side to figure out like some of those questions. For example, what the experience of past projects have been when they've tried to migrate to the CNCF Slack, what will happen to our users, and how much of the history would be preserved, and other things. So like we're currently on the limited plan. Would we get all of the history from the past? Or would it just be that limited history of 10,000 messages and other things like that? But yeah.
Do we want all of the history? There's some embarrassing comments I've made that I'd rather be buried.
I mean, I don't think it's the end of the world or not if we don't get it, but it'll still be good to have the info.
There are definitely things I've looked for recently that I couldn't find because they were past the history limit. That would be very nice to have back.
But definitely compared to some of the RFCs, this directly affects probably people here in this working group. So if you have an opinion, please chime in. Yeah, this wasn't meant to be a super long 15-minute one. Just heads up to please take a look and voice your opinion.
Cool. Anthony, something you want to do show and tell with?
Absolutely. Thanks. So I did want to talk about interaction mode for pack. I don't know if y'all recall the RFC that I put up months ago. The whole idea was basically that, you know, our community, I think we would say, has a lot of experienced engineers on board, right? Like our customers, our platform developers, right? Like I think we have a certain target audience already, and I was hoping we could broaden it up to, you know, more entry level, more casual developer, you know, that way we could sort of get, you know, just growth in a different market, right? And the hope was that by, you know, introducing a visual mode, you know, introducing something that lowers the learning curve a little bit, that introduces all the abstractions in a sort of more engaging way, we could sort of get there, right? So I've sort of been working on it in isolation for months now, and I was hoping to, you know, demo it, you know, just to see if it's worth investing in, right? You know, as a community. I'm, you know, believe it or not, you know, I don't feel strongly about anything. You know, this is really, you know, to see where it can go to solicit feedback, right? So I'm going to share my screen, and, you know, I'm just going to run the commands, show you what it's about, and I'll leave it up for questions. That's really about it. All right. Okay, sharing my screen. Y'all can see my terminal.
Yep.
Okay, so, you know, maybe a lot of us don't use pack on a day-to-day, which is fine. I'm just going to do a normal pack build. This is a simple Go application, just a really, really simple Go application. So we're expecting like a Go build of sorts here. Just to refamiliarize with what the default looks like, right? So this is what, let's say, a normal person who's introduced to build packs will see, right? They run this pack command, they're building their thing, they get some logs. Be patient, it's going through the phases. Okay. You know, keep in mind, you know, some of us are intimate with what's going on here, but, you know, someone who's kind of new might not get all the steps being provided here. But we know we have an export. There was a build phase that did some things, and then at the end of the day, we have this built image, right? So I was hoping we could try the same command now, but you know, if it's an experimental flag, right? But let's say you add this interactive flag, which is still experimental, but it is there. Let's try it and see what it looks like now. What is the user journey like? So we get a full terminal UI. We have this nice opaque doing something window here. It's sort of doing some things. We can just assume that it's optimizing some stuff. I don't know. Keep going.
Is detection really long for this app, or I'm curious? Detection is usually pretty quick.
That's a good question. It actually isn't. Because of a recent update, actually with SBOM, we're now reading the previous layer of the last image, and because of that, it's actually downloading like the last previous image in the analyze page, which is now first. But that's sort of a technical question, right? You're wondering. It's really just because this thing, which doesn't print out logs, is showing up, and because detect happens after, it's sort of waiting for this. That's sort of the reason, but we can talk about that later. But anyway,
yeah, that makes sense. Totally unrelated to this, we should figure out why that we're pulling the previous image there, because I think it's gonna slow things down. But sorry, keep going.
No, there's no problem. Anyway, so this is what the dashboard looks like now, right? We off the bat, you know, we have two concepts. We have our app and we have our builder images. You know, if in case I forgot what builder you're using, I was using Paketo Full, you know, my favorite builder. We see the run images, and, you know, sort of put in front of us are these build packs here, right? If we can cycle through these, we can select these, all right? I'm not going to explain anything. Like, it's supposed to be figured out as you go. So I'm just going to click one and then see what happens. Okay, we have a new view here. We have a dive-esque view, sort of broken out by phases, and in between the build phase, we have build packs, right? These are implementation build packs. right? We can cycle through these. Let's say I go to this one. I can hide things, I can go through here and hide folders as I wish, whatever. Let's go back. I go here, I can hide more folders. All right, so here's what I'm hoping is gonna happen, right? Like somebody who's smart, right, but not necessarily, well-versed in build packs is gonna say, okay, I think I get what's going on here. We have 3 build packs that were selected for me, whatever these build pack things are. The first one installed CA certificates for me. The second one downloaded Go for me. And then the last one did Go build, right? And that's what happened to my container image, right? I mean, ideally, I still really would love like the actual description to be written here, but this is just some metadata mishaps. But that's the gist of it right now, right? And the reason I'm demoing this now is because it's going to be part of the next release coming soon. Like this is already in an RC, so it's sort of, ready to be devoured by the real world. But I was gonna stop here and questions, concerns, feedback.
Can you click on one of the build packs again and go to the kind of interview? Yeah. So like in this screen, I really like how you have the phases instead of just the individual build packs in the panel, but there's no content on the other phases yet. Is the intent like, to maybe repeat the list or show something under detect that shows like, here are all the dependencies matching up, and then you can view information about those, or show something under export, like here are all the layers that got exported and here are their digests, or like, are you planning to build that phases thing out kind of more in the future? Because I really like how the information is organized there. I feel like that's like the clearest visual explanation of what the build pack process is I've ever seen.
Thank you for the question. To be honest, I wasn't planning on much more with the phases, right? There's a support Docker files RFC, which I think would introduce a new sort of extend phase. I was really hoping to depict that in here. Like, okay, once you do your Docker file command, we could show what's happening there. Also, I had ideas for SBOM, right? Plenty of people, Paketo has been begging for this. Like, hey, can I show my actual bombs? I think this is the perfect place for it. I really just wanted to show like what is happening in order here. That's really about it. And then whatever is like sort of you can drill into is the stuff that would be highlighted. And those are the only 2 things that's on my mind. To be honest, I didn't have much planned for detect or restore or something like that. But
I think this would be a great place to show like here's the grid of dependencies that got matched with other dependencies. So people, I think we have a problem with the transparency in the build process. Like people don't understand how the image is built to some extent, even though it's very clean and contractual. But I think we also have a problem of people don't understand how their build pack got detected. And this would be a great interface for showing like, this build pack, had these provided dependencies that matched, and then maybe in like red or gray, these didn't match, right? But they're optional. And then this other build pack, required these dependencies, and these other ones didn't match because they were optional. And then you could just get an instant visual representation of how your, the plan for your build, if that makes sense, through that detect interface. I mean, like not saying we shouldn't ship this immediately. This is great. The interface gives me a lot of ideas, if that makes sense.
No, this is good. I'm begging for ideas at this point. So I have noted that. Sam, I see your hand is up. What's up?
Yeah, really love the interface. I've been like using it with the RC release. I have questions on what happens if you use the publish flag, and what happens if the layers are not in the daemon. How tied is this to the daemon, and is it reliant on Docker, or is it just going to work with any of the lifecycle input-output options?
Great question again, which is sort of my point, right? Like everybody here is kind of really smart, but I don't know if it's a good representation of average developer. But yeah, great question. So it would work with publish flag. It really doesn't matter because what's happening is I'm streaming in the layers directory and workspace directory before the final thing happens. Does that make sense? So basically, it's just whatever the layers directory looks like will get dumped on here, right? But I have the ability to manipulate the data beforehand, right? I can depict certain files here if I want. I can splat it on the screen. So if you think about what publish does, it doesn't really interrupt this flow right now because it happens before that code path. Does that make sense?
Yeah. So what would happen with launch only layers that are like, so let's say a build pack has launch only layers and they're being reused on a rebuild with publish.
Yeah. So, you have to think of, those things matter in the final app image. This isn't, it looks like it, but it's not the final app image. This is the layers directory, right? So you're talking about launch layers and things like that. That matters in the final app image. That would only show up in the final apps and here, right? But things like build layers here would show up here. Cache layers will show up here too, right? So it's really up to me whatever I want to show, right? Whatever I want to hide. Does that make sense?
Yeah.
I think that brings up my not necessarily concern, but just point I wanted to bring up is that when we're looking at this like build and that information that you have the file system, it gives me the idea that these are the things that might be in my final app image, right? So if we were to expand on export and in the export actually show the app image, information or essentially a dive file system view of the final app image, I think that would clarify that so that that distinction of these are the things that are in my app image and these are the things that were just part of the build process. And you'll see that it's not a one-to-one correlation.
No, I like it. I guess that's the internal discussion I've been having. I really don't know. To me, there are already good tools for looking at the final app image. To me, the sort of the big mystery of this is the build process, like what's happening. So I guess I wanted it to be more of like making the learning curve for the build process easier. And if we need to add some explanation document to say, hey, this is not the final app image, go use actual dive for that or something like that.
Yeah, I think that was just the confusing bit, right? Like even myself, I was like,
yeah,
this could very easily be computed as part of my app image when it's really not at all.
No, that's fair, right? But I guess think of the pros and cons, right? Like this Go disk thing, right? Which downloads Go, right? There's no reason for the Go source code, right, to show up in the final app image. But as a person trying to learn about build packs, I want to know how it works. I want to know about this intermediate step about like this thing, right? I guess it's just about UI, right? Like I'm not a I can get some UI resources for that, right? But I hear your point and I appreciate it, and I'm just trying to tell you how I was thinking about it, right? It's just choosing one or the other.
I think this looks great. I'd love to see us continue to iterate on this. Great stuff. Yeah, I'd love to see like the cache and like whether the previous image existed or not, like with like a simple check or something at least, just to kind of know like, was there a cache image? Was there a previous image? And just so I can start to kind of put those pieces together in my head about what, seeing something under the restore phase that, at least the image name that we restored from or the cache directory that we restored from, just like you have the build here. It'd be kind of neat to be able to see what was actually in those committed cache directories or something.
I like that. I never even occurred to me. I think it's a great idea. I'm thinking about it.
Yeah, this is great, Anthony. I'm definitely in the line with Stephen for some of the other phases. Like, I feel like for me, even more so than build, like detect is one of the most opaque parts of the build process, especially when things fail or something. And it would definitely be, if you're streaming data from lifecycle on some of that, it would be neat to see like the build plan or like, I guess, some more data around detect. Because I guess it's great when it works, but it definitely is, I feel like, one of the harder parts to debug, because we, I guess, to some degree, swallow some of that input, or output rather.
Uh, it's just a good. I'm thinking about it. I like it. I'll think about it. That's all.
I think the screen with the phases is like it's like the best opportunity to have as much information as possible, kind of in a single place that diverts out to different things that you show on the pane. I really like the way you've set up the organization of the data.
Mhm. Yeah, I was thinking the same. There's similar thing of like the way that you present the concepts, like that. Like that's something important to think about, and can come like we should align that as we're talking about project descriptor and things like that. Like just that way of communicating to a user what's going on. Can you go back to the previous view? So where you have plan, is that really meant to be like build plan, or is this just like the list of build packs that are participating?
I don't feel too strong about it. I really just wanted, to me, like when I first started this, I thought it would be great to show build packs as like a bunch of steps, just like, hey, this is writing your Docker file for you. That was how I had it in my head, right? Like this is run step one, run step two. And again, I really wanted to pull the descriptions out of this, but the metadata wasn't working for me, not the right. So, to me, that would be a great way to like, it wouldn't be accurate, right? But it would be a great way to describe it to a newcomer, like, hey, this is writing your Docker file for you. So that was what I meant. It didn't mean anything with the actual plan file, that lifecycle.
Yeah, like you're thinking that the build phase is like the thing that people care the most about in terms of
yes,
like
that's
something
true.
analogous to Docker file. Yeah.
Yeah.
I mean, I think that's probably true. Although like I also agree with Terrence that like as you start to like debug, I guess like detect is probably the first thing that's really opaque and that you want to get insight into. But also wonder if like that other pane should just bubble up here, because like I agree with Stephen, it's really like a really good view of things, but I wouldn't want to like dilute what you're trying to go for there.
If you go to the other pane, it shows stuff across all build packs, right? But then like you clicked through on one of the build packs on the previous pane to get to this pane, and it just selected one of those ahead of time. That I do. It does look a little like on the first pane when you're clicking on one of the build packs, it's got a namespace to just that build pack, but then it goes to a screen that has everything, and it's just kind of one of them is selected. I not as strong. I think users will realize quickly that it works like that. But that is something that kind of, on Joe's point, makes me feel like maybe this thing could be even more higher level, but at the same time, like I don't want to waste screen space on generic metadata about the image when you could use it to do this kind of exploratory thing. I don't know.
Yeah, when I first saw your first screen where you had plan there, I thought it was going to be kind of like K9s or Dive, where you press like 0 or something and you'd see all the other build packs that weren't selected. Because I thought that was just a reinterpretation of like detect pass fail, which it kind of is, but that's what I thought was probably going to happen there. Just kind of, but it's
okay. I'm not offended. I like it. Please. Please. These are great. I did promise to keep it at 15 minutes, but please, if this can be an ongoing thing, you don't Slack me or make pack issues or whatever. I not doing it for myself. I really want this, things to work out for this community. So that was the whole gist. That's my whole presentation.
Cool. Looking forward to posting a cool tweet with a GIF of this. That'll go well. All right, I'll move on to the next one. Thanks, Anthony. RC for cosine integration.
Let me pull that up. Just want to give a brief overview of what the RFC is, and then I also want to talk about the divergence this might introduce in how we build images between the registry and the daemon. So cosine has become like sort of the de facto standard right now for assigning container images. As of last week, GitHub also announced integration with cosine so that you can now transparently sign your images. So you don't need to provide any keys or anything. If you're using cosine in your workflows, you can just do cosine sign the image name and it will automatically generate ephemeral keys and sort of push this out. The point is that like I think like this is becoming really popular, and I think we should consider integrating with it to like finish up our current like supply chain security epic. The reason that so this RFC currently suggests integrating cosine into the lifecycle directly instead of a platform like Pack. The main reason being that each platform would have to implement something like this for image signing. So rather than that, if the lifecycle provided it as an optional flag, platforms could have a consistent way of signing things and exporting them out. But if they want to implement their own logic, they can still just skip the flag entirely and do anything else they want with cosine if they wish to bypass it or change how they do it. Primarily, this flag is introduced to the analyzer and exporter phase. The analyzer phase uses this to verify registry access and a bunch of other things. The exporter takes it in to figure out what additional OCI images it needs to export. Cosine currently uses a convention to attach signatures and SBOMs to the main image. So it will look at the digest of the manifest of the output image and then generate a tag based on that convention to identify where the signature and the SBOM live. So these configs here are just like some normal values that cosine requires. There's the private key, there's a bunch of optional things, and then there are a couple of flags to export the SBOM and sign the SBOM if needed. The reason I wanted to bring this up is that because of cosine's convention, this can only work if you have the digest of the output manifest, which means that if we use this in the daemon mode, there wouldn't be anything to sign. And the other issue is that these are OCI artifacts, technically not images that Docker expects, so you can't load them into the daemon. If you try to load or pull one into Docker, it complains. So that's the other issue. But yeah, the idea would be if you're running Pack with a publish flag or and provide the cosine arguments to Pack, it will publish your image, sign it, export the SBOM if you want, and sign the SBOM also if you want in the cosine format. This does not, as of yet, remove the SBOM structure we have in the image right now for restore and analyze, just an additional way to export the SBOM, because if you want it to be exported in this way, you can. The other thing is like, we did discuss parts of this RFC yesterday in the implementation team. One alternative, if people are hung up on the daemon support, is Pack could potentially introduce a Pack publish command. So I was told that as of right now, there are already differences between doing a Pack build with a publish flag and Pack build and then Docker push because of the differences in how the daemon exports the layers with compression versus how, so the reproducibility part is already broken between the two. If we added like a Pack publish flag, we could at least guarantee that if you do a Pack build with a publish flag, or you did a pack build, loaded it into the daemon, and then did a pack publish, the output would be reproducible and the same. It also means that pack will then have to figure out a way to store all of these artifacts somewhere and do all the necessary operations when it does a publish. I have not included the pack publish parts to the RFC yet. I've just kept the RFC to conditional on the fact that this will only apply when lifecycle is run in registry mode. But if people have strong opinions on the publish part, we can add that. But that's the summary of this RFC.
This the publish flag question, I think, brings up an age-old question that has come up every few months for the last, I don't know, probably 2 years, is should we get rid of the daemon support in pack and replace it with a local registry or a local image store of some sort that's not the daemon, with support for loading it into the daemon, the same way we have support for exporting, but with a different source of truth. And also, does BuildKit help us here at all? Is maybe another question. I know BuildKit support is something we've talked about.
I think the terminology that you use, Stephen, might be a little bit wrong. I think we're trying to remove the daemon support from the life cycle, but I think pack would always want daemon support, right? From a user's perspective.
From a user's perspective, right? When pack, I just mean when you do a pack build locally, regardless of what ends up, like, yes, it is the life cycle that ends up talking to the daemon to export the image, but should that experience really use the daemon as a source of truth, or should it use the use some other mechanism of storing the image locally?
Yeah. I think we're on the same page. I just wanted to clarify that. That piece of it.
Yeah, the logic really lives in life cycle. Yeah, for sure.
So this, combined with a bunch of other RFCs I've put in, are all sort of facing the same limitation. They're trying to use OCI specification, and Docker doesn't follow all of it. And then we always hit a snag where we're trying to do some good things, but we can't because we're being held back with the difference between the daemon use case and the registry use case directly. The other alternative is exporting this whole thing out on an OCI layout format. So the good thing is that GGCR directly supports layout as a sink. So we would be able to add support for reading and writing out to it without potentially any changes in the lifecycle. It's just going to be dependent on the schema of the input and output references. So if the schema says, I'm forgetting the schema name, but it's like OCI layout : / and then give the output and can just load and export that way.
I think that's a nice feature, but I don't think it solves the underlying problem, which is what should the experience be when you pack build and you end up with an image in your Docker daemon and it has all the wrong kind of metadata on it, and there's no way to store information that you could store in the registry case, right? And so I think it helps mitigate some things, but I don't think we could that's not the same thing as storing everything locally on disk, with caching and the ability to reuse parts of that OCI image you exported in subsequent builds and things like that. So
have we verified that certain metadata is lost on the daemon when that is verified?
It's because there's no equivalent for it in the daemon. The daemon has no equivalent for the manifest. It's got an equivalent for the index, which is a manifest list in the daemon use case, and there's a config. So it dynamically constructs the output layers when it pushes to registry. So you also don't know which compression algorithm it will use. So you don't know what the digest of the final image would be. So all of that information is required if you want to do anything with if you want to sign things, if you want the exact digest of the image or anything else like that.
Yeah, I guess I'm aware of, basically if you create an image on the daemon, there's no place to put that sort of information. I guess what I was more curious about is if you pull something from the registry, right, into the daemon and then push it into another registry, does it persist the additional metadata?
No. I think Crane, as far as I know, is probably one of the only tools that has a way of migrating things from one registry to the other while preserving the digest. If you do a Docker pull and Docker push between registries, depending on how the daemon interacts with the other registry, you might end up with a different digest from the original image.
Yeah, okay, the digest, yes, I see what you're saying. I guess I was talking about the additional annotations and stuff like that. But if we ruin the digest, it might as well invalidate everything else.
The layers aren't stored in any compressed form locally. And so every time you push, you could use a different compression algorithm, there are many things that could change for every single blob. It could be different, not just, for some preset metadata in the manifest.
So the other thing is like the life cycle also being, I don't know if like what the outcome of this proposal would be, whether people are people think we should make it a requirement that packs should work the same with publish versus non-publish, and whether we can just say that cosine flags are only applicable when you do a pack build with publish, or whether we do want to introduce like a pack publish command on its own.
I think I would approve the RFC with just you can only use this in pack publish mode for now, and then iterate on it later. I think we should encourage more people to use pack publish because it's faster and there's a bunch of benefits to it. I think separately we should fix the daemon problem. We keep saying we're going to do it. That one of these days we should get around to it. Because all the on the SBOM topic, because the SBOM is stored entirely in the image right now, I think a nice benefit of that is that we don't have the problem with going between the daemon and the registry, because it's stored in image layers and you can always export it out. And so later, if you did a pack build locally and you wanted to generate a cosine, you did a Docker push to the registry and you wanted to sign that and generate the cosine SBOM and sign that as well, right? We could add functionality to do that because all the information would be available. And so that makes me not, I'm not concerned about figuring out how we're going to patch up that workflow later, because it's, should be very easy to support, very straightforward.
Cool.
Taking a step back, is there, what's the major advantage of Lifecycle doing this other than just each platform? Like, I know cosine's sort of the de facto leader right now, but I'm just, I know you have it in your drawbacks and alternatives. I'm just wondering, like, is it that hard to do cosine for a platform? Is it really worth us adding this complexity to Lifecycle in general? What's the big advantage for BuildPack's project?
I think the biggest advantages I see is like you can just reuse all of this across platforms. I don't have a strong opinion. We can also move it to pack. It's just the reusability aspect. And if we change things in the future with like how the exporter behaves or anything like that, like the cosine integration will come with it. Like the platforms don't need to do anything new to figure out how to find the output images, find the digest, sign them with cosine, and then push the SBOM if the location where the lifecycle outputs the SBOM changes or things like that. So it was mainly about like between different platform versions, API versions. That's one less thing for the platforms to care about, and it also puts a nice little check mark that hey, everything that you build out of build packs, like if you use the default implementation of the lifecycle, everything is signed if you wish it to be. Like it's fairly easy to integrate, and that's what I was sort of going for here. We can obviously just have each platform implement this. That's the other alternative.
Yeah, the downside with that though is like more recently I've been trying to push more stuff into the life cycle because from a platform's perspective, the maintenance aspect of it, it just doesn't scale. Like we're horizontally having to replicate the same functionality over and over again, and that's very costly. So if we're trying to increase adoption by being able to spread ourselves wide as far as the platforms that we can provide this sort of integration, I think it makes a lot more sense. And we've been trying to push other stuff into the life cycle, like the prepare and the project descriptor and stuff like that. So I think we've learned from that it's very costly to have to re-implement everything at the platform level. So unless there's like a sort of justification for not putting it in the lifecycle, I would say that should be the default for most features.
Yeah, I don't disagree in theory with that. I just don't know what, I guess maybe the RFC is missing for me the technical details on like with that config file, what is lifecycle export going to do? Like you mentioned a bunch of the stuff that like doing something with the SBOMs and like, yeah, I guess I'm wondering, I haven't done the effort of a platform integrating with Cosine, so I don't actually know what it looks like, the alternative of like each platform doing it. Like, is it as simple as calling cosines binaries with a few flags that are from that file, or do I have to go like get stuff out of the layers files or like inspect the image to build what I need to send cosine? Like, I guess I'm not clear on what that looks like from a platform direct integration.
So if like I have sort of worked on some of this. So in terms of exporting and signing the image out, like I believe lifecycle at the very end generates a report or something. I'm forgetting with the output images and the digest. So what we use is that output file that is parsed by the platform, and then for each of the cosine configs, it has to publish a signature using those values and the cosine. You can use the cosine CLI. Not sure if you can do it directly with the cosine CLI, but with a combination of Crane and cosine CLI, you may be able to do it. The way it was implemented in KPAC was just directly using the cosine as a library with a bunch of other things.
Okay, gotcha.
The SBOM part is interesting because I don't believe any platform that I know of right now supports the ability to like take the build pack SBOMs and output it in cosine format, because at the end of this whole thing, the SBOM, if it may not be present in like canonical locations which are part of the platform API. I think it's just that the platform will have to find out where all those SBOMs are and then run cosine attach for each of those files and push them out.
Gotcha. Okay. Yeah, it might be worth adding something to the RFC there just to kind of make it clear, like if we don't do this, this is kind of what a platform or what the platform is going to have to do to do this. Yeah, because I guess it just wasn't clear to me what that is. But yeah, if it's digging into all the file locations and doing a whole bunch of work with the cosine library, then I don't disagree that this should be in lifecycle.
The other good thing is like cosine folks are also pushing like cosine as a library, and they're building it on top of the same API that GGCR provides. So like the same concept of references and sinks and sources. So it should play very well with what the lifecycle already does with GGCR. That's also why I wanted this in the lifecycle, because this would also help us drive what we want cosine as a library to look like, and the upstream folks are like happy to take any inputs on what the like GGCR like library that they're exposing for cosine looks like.
I think Terrence called time, or at least notice for time, if we wanted to talk about the OCI layout, which probably ties in really well with the conversation.
Yeah, well, it's Sam's other topic that he explicitly asked for, so he's really just arguing with himself and how he wants to spend his time here.
Yeah, I guess if you're done with this, I can move on to the other one, which relates to like the OCI layout parts. I think like we sort of touched upon it a bunch already while we were discussing this, but I know Juan has worked on experimental PR on pack and lifecycle to support outputting to the OCI layout format. I just I'm curious what people's thoughts are on removing daemon support entirely from lifecycle, and lifecycle just being like OCI centric. Nothing Docker specific should be in the lifecycle, and then it should be the platform's responsibility for taking whatever inputs there are and converting it and putting it wherever they want it to be. The questions I had were mainly around like I saw that pull request currently outputs to a local directory as opposed to the daemon. I know Eric in the past said that when he was doing his POC with BuildKit, would have been easier if the lifecycle outputted to an OCI layout. I did not find any good reference on like how BuildKit, whether LLB, BuildKit LLB has some nice operations for loading an OCI layout image directly into the daemon or not. And whether it's just like we'll have to take all of those things and manually put it back into daemon, and whether we are happy with the slowdowns it might introduce, because right now lifecycle does some things to make the daemon export faster. The other thing is things like Podman all directly support loading images from the OCI layout format. So it also sort of, my next question was like, how tied are we to Docker in pack, and whether we should have like some native support for Podman. I know there's a blog that Javier has been working on for Podman support, but would it make sense to just have like a config flag that says, hey, use Podman directly natively versus use Podman with daemon support? So Podman works both in non-daemon and daemon mode. I think the blog we were working on was more around the daemon specific parts. Yeah. So whether we want just a lot of questions. The thing that I'm really hoping to get out of this is if we support the OCI spec directly, it's just going to make things easier for us in the future to like keep up with the spec and not have to worry about questions like how do we like think about how do we deal with daemon again, or that then ends up being a pack specific concern rather than a project specific concern. Like a project as a whole has to think about what we do for the daemon use case.
I see Anthony has his hand raised, but I'll add my little bit of flavor to this, in that I know I've talked to Emily right before she headed out on leave, and we were definitely on that path where we wanted to get rid of daemon support at the lifecycle level. And I think that's where the OCI layout effort, POC, and even some of the discussion about BuildKit came to be. So I am 100% for it, and I think it should be up to the pack to provide that sort of interoperability with the daemon or with Podman and stuff like that, and just push it at the platform level, because we've seen a lot more of a cost as opposed to a benefit for trying to support the daemon case. And that also simplifies our spec and the lifecycle implementation to actually adhere to other specifications, as opposed to a very one-off implementation of the daemon, which isn't really supported. Like Podman doesn't even really fully support their daemon socket API and that sort of stuff. Anyways, that's my flavor on it. I'm for it. Anthony?
Yeah, I know I have my hand up. Sorry if I'm cutting you off, Juan. I thought you wanted to speak, but I did want to say, if it gets removed at the lifecycle level, I'm sort of indifferent, but I would really like to see daemon support at pack level. I think you can tell by now I care very much about the onboarding experience, and I do feel like getting your image built directly into the daemon is a very not only conventional at this point, it's easier, right, to sort of wrap your head around. I don't think many people have even seen an OCI layout like directly on TARD, right? So that was just my 2 cents there.
I have similar worries. Like as a refactoring, the idea that lifecycle only supports exporting OCI layout on disk. I think there's a disadvantage from a user's perspective outside of PAC there, where like if you're using a builder and you're exporting directly to a registry, how is that something we're going to drop? I'd say probably not. We'd still want to modularize or do something to allow that OCI output of PAC to be exported to a registry in those cases, or sorry, OCI output of the lifecycle to be exported to the registry in those cases. But assuming we can patch that, right, or we have some extra module that you use when you create a builder that does the export, I'd still worry about to Anthony's point, in the PAC CLI case, what's that story for you do a PAC build and then you can treat the image just like the Docker image in your local daemon. I don't think we can get rid of that, right? I also worry about like caching. Like if we're gonna imagine we don't continue to support the daemon locally, if PAC exports things to OCI images, how are we going to share base layers? Is it going to be a problem that if you've pulled Ubuntu Bionic locally, you have to pull it again somewhere else, right, in order to share it? I think there's a lot of stuff to work through, like a lot of details to work through. I think I do see it more as a refactoring, or like a way to preserve more metadata locally, as opposed to like something that should drastically change the user interface for someone using Tecton or someone using PAC.
So just to clarify, I'm not proposing we drop daemon support from PAC. I'm proposing we drop it from the lifecycle. For PAC users, there would be no behavioral differences between these two things. Maybe it will be a bit slower because we're not doing the optimizations that we were doing before. But apart from that, simply in terms of the user experience that they've come to expect, that wouldn't change. They would still load things like into the PAC will still load the output into the daemon for them to use.
Why make that feature only accessible to users of PAC though? Why not like make it so that the lifecycle, one part of the lifecycle outputs things in OCI layout format, and then there's other modular parts that could go to a registry or go to a like why take that out of the lifecycle and make it just a PAC specific thing?
I'm just proposing we take out the daemon parts because there's loss of information there. I'm fine with keeping it in the lifecycle if there was no divergence in what the outputs of the lifecycle were. The only reason I'm proposing we drop it from the lifecycle is that there's loss of information, and should be like, at least from a platform's perspective, they should know the differences between like what they're possibly losing when they're exporting, when lifecycle's directly exporting to daemon versus not. Right now, I don't think lifecycle communicates all that extra metadata in any way if it exports to the daemon directly.
I think it's like going down that track, right? Say lifecycle, can only do OCI on disk and registry, something like that, right? Then if, in the future, if we think about how should PAC use that functionality in order to achieve that same goal of not losing information, we might keep a separate, like we might run a local registry or keep a separate local cache of images, and then have that automatically, load into the daemon at the end so that we preserve the user experience like Anthony was talking about. And so then we've taken the daemon stuff out of the lifecycle and then re-implemented it in a more complex way in PAC. Why not just do that more complex implementation in the lifecycle and keep PAC kind of dumb, if that makes sense?
Because of the specification piece, right? For me, I think it's always rubbed me the wrong way on the specification aspect of it. So if we look at the spec right now, it has daemon support. And so what we're saying is that for a, a lifecycle, another lifecycle implementation to be compliant, right? It has to support the daemon. And I think instead of saying that, I'd rather see it say, you know, the two supported methods are OCI layouts, which is spec, or registry, which is also spec.
Yeah, but I think you could also spec that the lifecycle, you know, any lifecycle implementation can contain any number of post OCI, like a valid lifecycle outputs OCI format, right? Any number of, you know, any lifecycle implementation can provide any number of valid export strategies post OCI format to different places, and then we can keep the functionality that might be useful for platforms, right? You know, somewhere that's not just specific to pack. Like I don't see a reason to take the more generic thing, right, and you know, put it inside of one particular platform implementation.
The way I see it is, at least in the wild, I haven't seen a benefit for anybody else to use the daemon on the lifecycle, only for pack. And the platforms that are using the daemon are using pack.
Same.
That makes sense. I've definitely seen platforms use pack to implement those builds. Do we feel like there's no benefit to not needing a nested container to do a build if your destination is going to be the Docker daemon?
I'm not sure I caught that.
It's like, imagine you're, you know, some SaaS CI runner, and you want to end up storing your image in the Docker daemon at the end, right? So that it can be, you know, run in a subsequent step, or, you know, something like that, right? If the implementation lives in pack, it forces you to do the build itself in a nested Docker container instead of in whatever container your platform natively provides. Like as a contrived example, say you're going to do a build on K8s, right? And you wanted to dump the image in the node and then run it immediately afterwards, right? You know, now you wouldn't be able to do that because you'd need access to the daemon to run the image, and you're not just using the daemon as storage. Like those are kind of two different operations.
But I think it's a very hypothetical, right? Where
Sure.
at right now it's like coming at an expense, right? And I think that's where a lot of alignment has come from both sides, saying that we'd rather not pay that expense until we see a use case that actually requires it. And we'd rather align with the existing specs, because you could do a lot of stuff with the OCI layout, right? Once it's on file, you could use different tooling to load it into whatever you want to. And yeah, you pay a penalty of that loading. But I guess, you know, that again, is it worth the expense of having to maintain and keep track of everything that we're currently keeping track of on the lifecycle side of things?
Is that going to make the daemon case slower for pack, because pack isn't going to be able to cache base images as effectively? If pack has to generate the final image in OCI format and then import the whole thing into the daemon, do we use like partial exports right now to our advantage, or does pack already, is that already something that happens under the hood?
I think that's one of the things that we were thinking about implementing. And I think a lot of this may be better served as a conversational piece if we create like a POC, right? Like we do a POC, see what the performance implications are, and see what we can do to remedy some of those. And then say, okay, you know, this is not that bad, right? Like, and then I think we would be a little bit more accepting and less concerned that way.
Yeah.
Makes sense. I'm not opposed to moving things towards OCI format. I just don't want to do it at the expense of the user experience. You know,
I think I can help with that part of the POC, because currently what I have was Lifecycle was exporting the image in the OCI format and letting the image in the layers directory, right? Then back, it's taking that image, that file from there, and then copy the file into my local machine as a user from pack perspective, and that's it. That's the output right now from my POC. Then you can see in your local directory, you can see the OCI image there. And then I was using another tool to create the bundle to actually run that image, right? So what I can do right now from that point is, okay, let me try to add some feature in pack to complete the workflow, right? Take the image and then probably push that into the local daemon, for example. And then we can compare, okay, how much it takes for the process to build the image using that way, right? Life cycle, exporting to OCI format, and then the pack tool to create the bundle and push that, and then using the normal way to let the life cycle to push the image to the local daemon, and we can compare both stuff. So that I can try to work on that.
Yeah, there's also a tool called Scopio that lets you do migrations, right, or copies, and maybe that's optimized, or maybe we could them optimize that to do your loading into the daemon.
For what it's worth, BuildKit also has like a few flags to directly interact with the container image store and export the image in a runtime bundle. So I am not sure if the Docker daemon does that, but if it's purely like the BuildKit implementation, it might be faster. I'm not sure. Just like skim through Eric's POC and through the BuildKit docs to see how things fit. But yeah.
But sorry, even if we do this optimization where we're not rewriting like layers that are already there, it's still going to be slower because the life cycle will write, it will complete its writing, and then pack will start its loading, right? So there's no way around some sort of performance impact.
Yeah, I agree with that. I think what we're curious about is how bad of a performance impact will it be?
Yeah.
So before we were able to parallelize, or like even did we have to write anything to disk before, or could we send stuff directly to the daemon? Like,
I'm pretty sure we still wrote to disk, no matter what.
to deal with calculating the digest, maybe before telling the daemon about the digest.
I think it might just be the standard method of working with image util, but I'm not confident right now on the exact answer to that.
Got it. We are way over time. Should we call this?
Yeah.
Yep.
So my current RFCs are not blocked on this, right? On daemon support for them.
No.